Right now we have Chris from chemistry.
Alright, suppose you were looking to build a house and you needed to hire a contractor. Would you rather hire an expensive contractor who is experienced and well established, or a cheaper contractor who hadn't yet proven themselves? Well, sorry about that. Of course, if money wasn't an issue, we would all prefer to hire an experienced contractor because we had more confidence in their ability to get the job done. As it turns out, pharma companies use the same type of logic when it comes to choosing chemical technology to use for the synthesis of drug compounds. They survey the literature and they pick out methodologies that are the most proven and the most established, even if it means breaking the bank. For example, one of the more popular reactions or steps involved in the making of drug compounds is a palladium catalyzed reaction that uses abundant feedstock materials such as ammonia to make new carbon-nitrogen bonds, which can be found in virtually all drug compounds, such as the one shown here. Now, the problem is that you have to use palladium in this reaction, which is incredibly expensive, and because of that, these drugs can often be difficult to synthesize at an extreme cost. So palladium is like an experienced contractor because it's well established, well understood, and so pharma companies trust it. In fact, they trust it so much they're willing to ignore the fact that it's incredibly expensive and incredibly rare, which really shouldn't be a surprise given that we get our palladium supply from asteroids that strike the Earth, so it's really not a reliable So maybe I'm being a little tough on pharma. Maybe they have to use palladium because there are no other suitable alternatives. Well, even that's not true, because for over 20 years we've known that nickel, an incredibly cheap and abundant metal, can do many of the same type of things as palladium, including catalyzing those important carbon-nitrogen bond-forming reactions I alluded to earlier. So the problem is that nickel is a much more reactive metal than palladium, which means it's difficult to control and get to do only the things you want it to in a chemical reaction. As a result, much less research has gone into nickel research relative to palladium, and so pharma companies, understandably so, are reluctant to use nickel because while palladium comes with a price tag, it also comes with a user manual. And that's where I come in. I've spent the last several years trying to convince pharma companies to abandon expensive palladium-driven processes in favor of nickel. And to do this, two major things needed to be accomplished. First, the developed nickel technology would of course need to be on par with palladium in terms of performance. And secondly, and most importantly, we need to understand exactly how this catalyst operates at the molecular level. After several years of experimentation, I was able to tame the reactivity of nickel by attaching a very particular phosphorus-based compound to it called a ligand, which tunes its behavior and gives me control over its reactivity. I have since patented and commercialized this nickel catalyst, and I'm proud to say it is among the world leaders in carbon-nitrogen bond-forming reactions. But before drug prices can start to drop, we first need to understand exactly how this catalyst operates, and the hope is I'll have both the product and the user manual ready for pharma by the end of my time here at Dalhousie. Thank you so much.